Hi everyone, thank you for joining me again. So in this video, we're going to do more examples on transformations of functions. More specifically, we will be talking about vertical and horizontal stretching and shrinking of a function. So let's get started. So let's take a look at what is vertical stretching and shrinking. So take a look at the blue graph here. We have f of x is equal to square root of x. Now, if we were to obtain the pink graph from the blue graph, we would have to multiply each y coordinates of the function by 3 because this 3 is representing multiplying the function value by 3, which will be a vertical stretch. Now, to really understand that, let's grab a point that's on the graph. So as you can see, if you grab the point 1, 1 that's on the blue graph, and you want to obtain the graph of 3 times square root of x, we'll be multiplying the y coordinates by 3. So you'll end up being at the point 1, 3, and so on. Take a look at another point. So say we want to analyze this point. Let's do something nice, like say 4. So 4, 2 is on the graph of f of x equals square root of x. If I want to obtain the graph of 3 times square root of x, I'll be multiplying the y coordinates by 3. So 2 will get multiplied by 3, which will give us 6. So this point will now move up to 3, 6. And then if you connect these point 1, 3 and 1, 4, 6, you'll obtain the graph of 3 times square root of x. Now let's take a look at the next function, which is multiplied by a factor of 1/2. So what is this factor is going to do? Well, it's going to multiply each y coordinates by 1/2. So 1, 1 will now become 1/2. And then if you look at 4, 2 will now become 4, 1, because we shrink the y coordinates by a factor of 1/2. So what can we say? Well, if this number in front of the function, if, for example, the first one, if it's greater than 1, that is a vertical stretch. As we saw on the graph, the pink graph being stretched by a factor of 3. And if the number in front of the function is a fraction, then it is a vertical shrink. So that's why the graph looks more flat toward the y-axis. Now let's write this down in more general form. So if we have y equals some constant c times the function f of x, and if c is greater than 1, then that's a vertical stretch. And if we are graphing again y equals c times f of x, where c is a fraction, so it's between 0 and 1, then it is a vertical shrink. And that's the illustration we saw right above. Now let's take a look at what is a horizontal stretch and shrink. Now again, we're looking at the function square root of x. So that's the blue. This is our function square root of x. Now to obtain the green and the red graph, let's see what we're going to do. So horizontal stretching and shrinking, meaning you're changing your x coordinates by some number c. No, so here the green graph represents y equals square root of 3 times x, and the red represents y equals a square root of 1/2 times x. Now note the difference between this one and previous one. So for the previous one, we had these constants outside the function, and 1/2 was also outside. But now for this one, they're actually inside along with your independent variable x. So that's what makes it a horizontal stretch and a shrink. Well, now let's take a look at it closely. So if we multiply the input value by 3, this means that we're going to divide our each x value, x coordinates, let's say, by 3. Or you can think of it as multiplying by 1/3. So take a look at this point. So we know 1, 1 is on the blue graph. And if I want to obtain the green graph, I would multiply 1, 1, 1, which is the x coordinate, by 1/3. So that will end up right here. So that's the x coordinate that's being shrinked horizontally by 1/3. And then if you want to graph another point, you can also do the same thing. But you can see that the green is a horizontal shrink by 1/3. Now let's take a look at the red one. So the red one, again, we're going to divide each x coordinate by c. In this case, c is 1/2. Dividing by 1/2 is same as doing multiplying by 2. So now again, take the point 1 and now multiply by 2. Now it's going to become 2, 1, which is right here. So this graph is representing a horizontal stretch. So your x values are getting multiplied by 2, which meaning it's becoming larger. So what we can say from here is that if you have y equals f of c times x, meaning you're multiplying the input value by some c, this means if c is greater than 1, then it is a horizontal shrink by 1/c. And if we have y equal f of c times x, again, you're multiplying the input value by c. If c is a fraction between 1 and 0, then it is a horizontal stretch. As we saw it in the example above, when we multiply the input value by 3, we got the graph being shrinked to 1/3 for the x coordinates, which represented by the green graph. And when we had the graph square root of 1/2 x, we stretched the x coordinates by 2, so we have the red graph. So these two are the basic definitions for horizontal stretch and shrink. Now let's do an example combining these two ideas. So here we want to graph g of x and h of x. So let's first do g of x. So g of x, I'm going to rewrite, we have 2 times 1/x. So we know our basic function is this function right here. So that's 1/x. And then the 2, it's multiplying the function values, which means this is a vertical stretch by 2. So all the y coordinates are going to get multiplied by 2. Now let's take a look at the graph. So hopefully you remember how 1/x looks like. 1/x looks something like this. Okay, so now let's grab a point that's on the graph. So we know if I plug in 1, we have the function value 1. So 1, 1 is on the graph. So if I want to obtain g of x, I'm going to multiply the y coordinates by 2, which will give me a vertical stretch of 2. So 1, 1 is now going to become 1, 2. So that's right up here. And then we just maintain the same shape. So our graph would look something like this. And then same thing on the other half. If I have -1, -1, that point is also going to get stretched by 2. So the point will lie on -1, -2. And then we just preserve the shape. So here's the graph. The pink is representing g of x, which is a 2/x. The graph has a vertical shift of a stretch of 2. Now let's take a look at h of x. h of x, we have 1/3 x squared. So let's identify what kind of stretch or shrink that is. Now here you're multiplying 1/3 inside the function. What that means is it's a horizontal stretch or shrink. But the c here is 1/3, which means it's a fraction. So that means it's a horizontal stretch by 3, because dividing by 1/3, it's same as doing multiplying by 3. So all the x coordinates are going to get multiplied by 3. That's what a horizontal stretch is. So we're going to take the x coordinates and multiply them by 3. So let's take a look at how that's going to be. So here, x squared is the basic graph. So x squared looks like this. It's a parabola. And then let's grab a point that's on the graph. 1 is on the graph. And then we are going to multiply each x coordinate by a factor of 3. So 1 gets multiplied by 3, we have 3. So we have the point 3, 1. And then let's pick another point. So we know -1 and 1 is also on the graph. If I multiply -1 by 3, I get -3, 1. So that's this point. And then by connecting them, we still have 0, 0. Very weird parabola. It's being stretched so much by 3. So I'm going to do my best to connect the other half and make it symmetric. So here is the other half. So you can see this graph is stretched horizontally by 3. So the pink is our function h of x, which is 1/3 of x squared. Yeah, sorry, my illustration isn't the best, but hopefully the idea makes sense. All right, so that's it for these transformations.